everyone! This lesson is about neutralization reactions, or what happens when we mix an acid and a base together. And a lot of you have already done this before in your lives. If you've ever put baking soda together with vinegar, or in lab we did baking soda together with sulfuric acid, you're going to get some bubbling action and some chemical change taking place. Not all acid-base interactions are that bubbly and exciting, but they're all going to follow the same general pattern, and that's this. If I take an acid, and we'll go back to our Arrhenius definition of acids and bases. Acids as our source of H+, bases as our source of OH-. When I combine those two things together, I'm going to get out water from our H+ and OH- combining. I'm just going to write that as HOH, which is the same thing as H2O, right? And I'm going to get some ionic salt because we didn't just add pure H+. Maybe we added HBr, HCl, HI. We didn't add pure OH-. Maybe we added NaOH or KOH or something different, something that had a source of OH- within it. So we're also going to get out some ionic salt. So this reaction down here at the bottom is a classic example of a neutralization reaction where we're combining HBr, our acid, because it's got that source of H+, with KOH, our base, it's got that source of OH-. And when we mix those two things together, what you may see is just a very specific example of a double replacement reaction. And that's all that neutralization is. You're just going to need to know that word, neutralization. Because when I combine my H+, I'm just going to even cross it out on the left, with my OH-, I create H2O, which of course is neutral, hence the neutralization name. And whatever is left over is going to combine to form my ionic salt. In this case, the only thing that was left over when I crossed out my H and OH to make water was potassium and bromine, and those can combine to form KBr, my ionic salt. It's going to be essential to know that this general pattern takes place when you combine an acid with a base. You will always, always, always create a salt and water. And notice that salt doesn't have to be table salt. It's just really any ionic substance. So what I do want to know for this particular example problem is what acid and what base do you have to mix together to create water and table salt, or NaCl? So I'm going to support my answer with a neutralization reaction. And right now I know the products. I've got water, H2O, and I've got sodium chloride, NaCl. So somewhere, by combining together, again, H+ and OH-, I got water. So I know my acid has to be a source of H+. I know my base has to be a source of OH-. And now all I need to do is put the correct ions paired together with my H and OH. Well, Na is positive, so it can combine with my negative OH-. So I have sodium hydroxide. Cl is negative, so it can combine with my H+ to form HCl. So if you mix together hydrochloric acid with sodium hydroxide, my H and OH will neutralize and form water, and my remaining Na and Cl will form table salt. We can take a look at a practical example of these neutralization reactions by looking at wasp stings and bee stings. Wasp stings tend to be slightly basic, whereas bee stings tend to be slightly acidic with the compounds that they put into your skin. So vinegar can actually be used as a very home temporary treatment for a wasp sting, but it can't be used for a bee sting. So if it's helping relieve some of the pain from a wasp sting that's slightly basic in nature, that must mean vinegar is slightly acidic, and the base plus the acid are combining to form water and some salt, right? And if we have water and salt, that's a lot more pleasant than some basic compound sitting on your skin. But if I try and combine the acid from the bee sting with the acid from the vinegar, that's no relief for you, right? So these neutralization reactions can help do things in very practical environments, but also, again, in a reagents chemistry context, what we're doing is just mushing together that H+ and OH- to create water and some salt as a byproduct.